Okay, so here in this video, I'm going to take you through the free response questions I just wrote, guys, for your test coming up. Sometimes I discover an error when I didn't work them through, so I'll discover that with you here. All right, so we got particle B moving along an x-axis for time greater than or equal to 0, and its velocity for B is given as such. And this first question is on calculator. So we're to find the acceleration at particle B at time t equals 3. So we need to write that the v prime equals acceleration. And the derivative of 1 is just 0. The derivative of e is the function itself times the derivative of the exponent. So there is the acceleration function. And the acceleration of particle B at time t equals 3 just means to replace t with 3. And I don't even need to do this much, guys. That's good enough. All right, remember E is just 2.718, so E is getting closer to 3, but not quite. Okay, so it's just under 3. Is particle B's speeds increasing or decreasing at time t equals 3? So we need the acceleration at 3, which we have, is negative. And then the velocity at 3 is from above. So this is the velocity here. So this is 1 plus e to the 1 minus 3 power. So this would be 1 plus 1 over e squared. Okay, so let me just make sure I see that correctly. So the velocity of particle B is what's given. That's this expression right here. I'm just replacing t with 3. So e to the negative second makes that 1 over e squared, which is clearly greater than 0 because remember, e is always positive, but that up here, this negative in front will always make it negative. So since the acceleration at time t equals 3 is negative and the velocity at time t equals 3 is positive, we would say that the speed of particle B is decreasing. So speed is decreasing or slowing down because the acceleration of particle B at 3 is less than 0, and the velocity of particle B at 3 is greater than 0. Find all values of t for which particle B is moving to the right. So I need its velocity, which is given to me right here. So let's see here. So this is its velocity. So 1 plus e to the 1 minus t. That is the velocity. And this is always positive right here. So no matter what. So therefore, particle B is always moving to the right. So a little awkward question. I think I was thinking of something else, honestly. But it gives you something to think about, though, as far as functions go and understanding functions. E right here is always positive, regardless of what t is. It may be a small positive number, or at times a large, positive number, but it is always positive. So therefore, particle B is always moving to the right for time greater than or equal to 0, because the velocity at any time is always greater than 0. Kind of didn't want that to happen there, all honesty. Again, I probably was thinking of something else on the fly there. Yeah. And this is the velocity of particle A now. So we're given a graph of A, and this is the velocity. So this is time versus velocity. And we want to figure out the time from 0 to 7, not including the endpoints, when the speed of particle A is increasing. So that means velocity and acceleration have the same signs. So here, velocity is all positive, so I'll do that on one side, I guess. And here, velocity is all negative. And then velocity is positive. So acceleration is the slope of this graph. So all slopes are positive here. Notice the acceleration won't exist at those corner points. And here, all slopes are negative. All these slopes are negative. And then all these slopes are positive. All right, it's got to look carefully here. When do I have the same sign? From 0 to 1, because everything is positive, both velocity and acceleration. And then also from 4 to 5, because both velocity and acceleration are negative. And then as well as from 6 to 7, because that's when velocity and acceleration are both positive there. When am I slowing down would be when velocity and acceleration have opposing signs. So that right there would be from, oh, I stand corrected here, guys. I didn't see that too well. 0 to 2. Sorry about that. So that's 0 to 2. So from 0 to 2, velocity and acceleration have the same sign, as well as from 4 to 5, and as well as from 6 to 7. Now, this is speeding up. When am I slowing down? If I don't butcher this to death here, this would be from 2 to 4 because velocity and acceleration are opposing signs, and as well as then from 5 to 6 because that's where velocity is negative but acceleration is positive. And I think I'm pretty good now up there. I think what I'm a little bummed out about with this question is right here is when it's moving to the right, but it was a very good analysis of understanding this function because this velocity function is always positive. 1 is clearly positive and E is always positive. So this particle was always moving to the right, never reversing direction. I'm going to come back to question 2 because it entails the calculator. Part 3 is non-calculator. So the average rate of change is the change in y's over the change in x's. So this is nothing more than f at pi minus f at 0 all over pi minus 0. It's the slope of the secant. So f at pi is just going to be found by replacing x with pi, and the cosine of pi is minus 1, and my answer is there, negative pi. F at 0 would be 0 times the cosine of 0. Well, that's just 0, guys. That's pretty easy. So negative pi minus 0 over pi reduces to minus 1. What's the slope of the tangent line of f at x equals 3 pi over 2? That means I need the derivative. So f prime of x is the first times the derivative of the second plus the second times the derivative of the first. And f prime at 3 pi over 2 means 3 pi over 2 times negative sine of 3 pi over 2 plus the cosine of 3 pi over 2. So 3 pi over 2 is a quadrantal angle. It kicks me down here. Sine is the y coordinate and cosine is the x. So sine of 3 pi over 2 is this minus 1 times that negative is a positive. So it looks like that's positive 3 pi over 2. And the cosine of 3 pi over 2 is 0. So therefore, my slope comes out to be 3 pi over 2. Part C is g is a differentiable function such that g at pi over 2 equals 0. So remember, if g is differentiable, g is also continuous because differentiability implies continuity, but not the converse necessarily. The graph of at g prime, the derivative of g is shown below. Find this limit. How do we approach a limit? By direct substitution. So the limit as x approaches pi over 2 of f of x is right up here. This is f of x. And when I do that, it's pi over 2 times the cosine of pi over 2. Well, pi over 2 kicks me up here as a quadrantal angle. Cosine is the x coordinate there at 0. Well, it is 0. And 0 times pi over 2 is 0. And then I need the limit as x approaches pi over 2 of g of x. And I'm told that g is differentiable, so therefore it's continuous, which means the limit as x approaches pi over 2 is going to equal the function value of g at pi over 2, because that's what happens for functions that are continuous. The function value has to be equal to the limit value. So this value, 2, is 0. So I show that the limit of the numerator is 0, the limit of the denominator is 0. What rule can I use? L'Hopital. So it's going to be the limit as x approaches pi over 2 of the derivative of the top, which is f prime, over the derivative of the bottom, which is g prime. So remember, it's not a quotient rule to do L'Hopital's rule. It's just the derivative of the top divided by the derivative of the bottom. This is the graph of g prime. And as we approach pi over 2, that value there is 2. Now let's see if we could save some work here. I guess not. So now I need to find the derivative of f, which I have though, guys. I think I have it up here. So I'm just going to recopy that. So f prime of x is negative x times the sine of x plus cosine of x. I'm going to replace that with pi over 2. And just replacing x with pi over 2. And the cosine of pi over 2 kicks me up here. And the cosine is the x-coordinate, which is 0. The y-coordinate is the sine of pi over 2, which is just 1. So my answer there is negative pi over 2. So this answer on top is negative pi over 2, which now reduces to negative pi over 4. So again, just to talk you through that, how do we take a limit? First is by direct substitution. And I took the limit of the top, which came out to be 0 by direct substitution, and the limit of the bottom, which also came out to be 0. Then I did the derivative of the top, which is just f prime. The derivative of the bottom is g prime. This is the graph of g prime, and g prime at pi over 2 is 2. And then I had to take the derivative, which I found before. No need to redo it all over from scratch. But this time I had to replace x with pi over 2. And the sine of pi over 2 is 1 times negative pi over 2 is negative pi over 2. And the cosine of pi over 2 is 0. And in part D, again, I made these up on the fly. Let's see how they work out. It's the inverse rule. So g prime at 4 equals 1 over h prime of g at 4. Step 2, not f and g, it's g and h. And let's see how I did here. So this is 4, and that's 4 there. And oh, no, I need g at 4. Ooh, I was a little worried there. I need g at 4. Okay, so here we go. So I'm going to set h equal to 4. So it's 2x squared plus 2 equals 4. You could actually solve this one. I could subtract 2, divide by 1, and x equals plus or minus 1, and we only want the positive x. Or you could have seen by inspection that 1 squared is 1 times 2 is 2 plus 2 is 4, so it works. So again, just to make sure, because I wrote these up on this morning, 2x squared plus 2 is h, and the inverse of h is g. They're inverses of each other. So g prime at 4 equals 1 over h prime of g at 4. I start on the inside, so that means a 4 here, means a 4 there. So I set h equal to 4. I like doing this right here like that. And that gave me a value of 1. So g at 4 is 1. And now it's 1 over h prime at 1. Well, h prime of x equals 4x. And then when I replace x with 1, h prime at 1 is 4. And my answer is 1/4. And the last one is calculator active, and let's see how I did there. I'll bring this up and share that screen. Just reduce this down a little bit. Or you know what, actually I'm going to use is Desmos. I'm going to use Desmos here. Why not? Because it seems to be a little easier sometimes. I'm just going to add, let's do Desmos here. And I'll add that, and let me delete that. Or I'll close that out. And let me see if I can just do a shared screen there with Desmos. Okay, pretty good. Just maybe if I could shorten that a little bit, but then sometimes I make it a little bigger. All right, so let's use Desmos here. So v at t equals 6 plus cosine of I think, can it use t? I think so. Let me try that. I usually always use x, but yeah, I think it's okay. Yeah. I don't know why I thought otherwise there. Oop. Nope, I think I need my glasses on so I could see. 3 sine of 7t divided by 40. Okay, so there is my velocity. Maybe I have to, this is the hard part is with these screens is, you got to make them, I'm only going from 0 to 40. So find the acceleration of the plane at time t equals 14 minutes. So that's just going to be v prime at t equals a at t. So I guess I can just do this. Why not just go v prime at 14? And there it is. For this one here, though, you need to say that v prime at 14 equals a at 14, which is negative 0.5029. And the units of measure would be miles per minute per minute. Just make sure I typed it incorrectly, because I have nothing to check answers with here. If I can make that a little bigger. So I have 6 plus cosine of t divided by 10 plus 3 sine 7t over 40. And I want v prime at this. That's negative 0.5029. Is the plane speeding up or slowing down at time t equals 34 minutes? So I need v at 34, and I need a at 34 minutes. So v at 34 equals 4.0523. And then I just need this to become 34 now. And a at 34, which equals v prime at 34, which is 0.52168. So the velocity at 34 is positive, and the acceleration at 34 is positive. So therefore, it's speeding up. So it's speeding up the plane at t equals 34 because v and a have the same sign. All right. Find all values of t for which the speed of the plane is 8 miles per minute. So speed is the absolute value of velocity. Speed is the absolute value of velocity. So what I find is easier is to just subtract the 8 and to calculate the 0. So I'm just going to subtract the 8. So I'm just going to do v at t. Minus 8. And it did not graph that. So in other words, I'm going to have to call that something. So you have to call it a y or call it a different function. So you have to do, ooh, I need the absolute value though, even though it's always positive. Oops, so sorry there, guys, I didn't put that in. So it is the absolute value of v at t minus 8, yes, even though I knew it was always positive. So here, when is the speed going to be? That's beyond 40, by the way. So I could see that my 1, 0 here is at t equals 1.981, 1.981, and as well as another time, 14.163 minutes. This time over here is beyond 40, so we're only within the 40. So I'm trying to think on Desmos, another way you could have done that. If you take away this, again, speed is the absolute value of velocity, and that had to be considered there. Yeah, it gives you that question mark. So it just even tells you, try adding y equals, okay? And then now when you graph this function, like I did here, you had found the zeros, you know? Next up is find the average acceleration. So average acceleration is the change in velocity over change in time. So it's the velocity at 30 minus the velocity at 10 over 30 minus 10. And you do not need to show us intermediate steps there. So here, we're just going to do parentheses, be very careful, of v at 30 minus v at 10 divided by 20. And that's my average velocity, or average acceleration, sorry. Which is, again, miles per minute divided by minutes. And how do I get that? Oh, that went too far. Is that velocity is measured in miles per minute and time is measured in minutes. So that there completes everything. That's what I said, I like the Desmos that it's easier in a way to get the zeros and to get the graphs pretty fast. But man, it does limit the size of the screen. For me, that sometimes is difficult. So again, I liked all these questions. Part C on that first one, again, I thought it could have come out to be something a little more interesting where you had a factor and do a number line test. But it also is good to understand the functions, that this function is already positive, so it's always moving to the right. Other than that, everything else worked out to be pretty nice, I felt. This calculator active question, nothing too much going on there, just finding the acceleration at a particular time, and then comparing acceleration and velocity at time t34 to see if it's speeding up or slowing down. And then don't forget that speed is the absolute value of velocity. And you can see that my mistake over here, it's so easy to leave out the absolute values because you get so bogged down in entering in the information that you forget that. But when you write this out, you would get a point for that because that indicates that you know the setup for that problem, okay? And this down here is just strictly, be careful with the parentheses. It's v at 30 minus v at 10 all over 20. That's just that value there. And then in question 3, we had to invoke L'Hopital's rule down here because we got 0 over 0. Some nice product rules. And please remember your trig. And then this is the inverse rule. So here in this one, we got L'Hopital's rule, which you'll see on your test, and the inverse rule right there. And this was nothing more than, taking the derivative and evaluating it at a point to get its slope. All right, and I hope that helps.